My dear learners of Standard 8, welcome back to my today's online class. Previously, we had completed the history and the development of the artificial satellites. Today, I am going to discuss on the movements of an artificial satellites and the importance of artificial satellites. Actually, for the orbital motion of a satellite around the Earth, there must be a centrifugal force or centripetal force that is working inwards is needed. So first we will know about the motion of a satellite. What is the motion of a satellite? The motion of an orbiting satellite can be described by the same motion characteristics as any object in circular motion. The velocity of the satellite would be directed tangent, that is to the circle at every point along its path. So what is tangent? A straight line or a plane that touches the curve or curved surface at a point, but if extended does not cross it at the point. So before going to discuss the movement of an artificial satellite, we need to know the centripetal force and the centrifugal force. What is centripetal force? That is, for the orbital motion of a satellite around the Earth, there must be a centripetal force that is working inwards. This force comes from the Earth's gravitational attraction. So centripetal meaning and definition of a centripetal force. The word centripetal refers to a tendency to move towards the center. Centripetal means to proceed in a direction that leads to the center. Furthermore, centripetal force refers to the force that keeps an object moving in its circular path and helps it to stay on the path. And another one, what is centrifugal force? This is the outward force. So is an outward fictitious force that is experienced by an object moving in a circular path directed away from the center of rotation. It is directed away from the center of rotation, and it is refers to a tendency to move towards the center. The direction of this force is away from the axis of rotation and is parallel to the axis of rotation. So it's the centripetal force, and this arrow is defined the centrifugal force. So centripetal force the inward force and centrifugal force is the outward force. Now we will know what is the force of gravity. So follow, it is the Earth and this is the artificial satellite. So artificial satellite moves around the Earth. So it is to say that a satellite is an object upon which the only force is gravity. So once launched into orbit, the only force governing the motion of a satellite is the force of gravity. Newton was the first to theorize that a projectile launched with sufficient speed would actually orbit the Earth. Next, I will discuss about the speed. Now follow what is the gravity in science and what is gravity on Earth. Gravity comes from the Latin gravitas, that is weight, or gravitation is a natural phenomena by which all things with mass or energy, including planets, stars, galaxies and even light, are brought towards one another. On Earth, gravity gives weight to physical objects, and the moon's gravity causes the ocean tides. So what is gravity on Earth? Gravity, the force that pulls things to the ground on Earth. And the force of gravity also exists on the moon, but it is not as strong as it is on Earth. So artificial satellite moves using the centrifugal force and centripetal force also. So for this orbital motion of a satellite around the Earth, there must be a centripetal force that is working inwards. So the calculation shows that to launch a satellite into an orbit round the Earth, a speed of about 8 km per second is needed when the satellite is lifted about 250 km from the ground. So when the satellite is lifted above 250 km parallel to the Earth, the speed is needed about 8 km per second or 28,000 km per hour. But it is not an easy matter to apply so much velocity to an object at this height. Now follow, how does a satellite move around the earth at just the right speed? It will move around the earth in a circular motion. This type of motion and the path that a satellite moves is called an orbit. This path is known as orbit. Close to the earth at an altitude of 100 km, a satellite needs to be moving at 8 km per second or 28,000 km per hour to stay in the orbit. So I told you it is not an easy matter to apply this such velocity to an object at this height, because what? That is, the intense friction with the atmosphere will create as much temperature that the object will be burnt and turned into ashes. Now, launching procedure of a satellites. The process of placing the satellite in a proper orbit is known as launching process. During this process, from Earth stations, we can control the operation of satellite. Mainly, there are 4 stages in launching a satellite. First stage what? The first stage of launch vehicle contains rockets and fuel for lifting the satellites along with launch vehicle from ground. Second stage, the second stage of launch vehicle contains smaller rockets. These are ignited after completion of first stage. They have their own fuel tanks in order to send the satellite into space. Third stage what? The third stage of the launch vehicle is connected to the satellite firing. This firing is a metal shield which contains the satellite and it protects the satellite. And fourth stage, satellite gets separated from the upper stage of launch vehicle when it has been reached to out of Earth atmosphere. Then the satellite will go to a transfer orbit. This orbit sends the satellite higher into space. When the satellite reaches to the desired height of the orbit, its subsystem like solar panels and communication antennas gets unfurled. Then the satellite takes its position in the orbit with other satellites. Now the satellite is ready to provide services to the public. So these stages, why we are using the different stages to launch a satellite. So this speed that is achieved by using a multi-stage launching system, because what? Follow first stage, I have told, as the first stage motor uses up its fuel, then drops off. Second stage, rockets does not carry its weight, then the speed is increased stage by stage. Then third stage, fourth stage, because at lower atmosphere the air friction is larger for its higher density of air. This can create enormous heat and burn the rocket. For this reason, the speed of this launching vehicle increased stage by stage. Then the satellite begins to revolve around the earth. So this is the model of an artificial satellite. Here you are observing, then transceiving parabolic antenna. It is the combined radio transmitter and receiver, both sides. So artificial satellites are used for different purposes. There are different types of artificial satellites according to their uses. So now follow. These are the dish antenna which are in the ground, and it's the artificial satellite. So first of all, from the ground, this equipment transmits signal to the satellites. Then satellites amplifies the incoming signals and changes the frequency. Then third stage, signal is transmitted back to the earth, and the ground equipment receives the signal. So dear learners, we often communicate with the outside world over telephone. So when we use the telephone or the radio wave is sent through a dish antenna from our country to an artificial satellite, and the satellite transmits the radio signal to the antenna of the receiving country, and from there it reaches the telephone of the persons with whom we are talking. So by this type of satellites, we also watch different types of cultural functions, games, World Cup, also Olympic Games held in various countries through artificial satellite. So communication satellite. I told you there are different types of artificial satellites. These are the communication satellite, weather satellites, Earth observation satellite, military satellite, navigation satellite, and astronomical satellite. So what about the communication satellite? Communication satellite is an artificial satellite that relays and amplifies radio telecommunication signals via transponder. It creates a communication channel between a source transmitter and receiver at different locations on Earth. Communication satellites are used for television, telephone, radio, internet, and military applications. As of 1st August 2020, there are 2,787 artificial satellites in Earth's orbit, with 1,364 of these being communication satellite used by both private and government organizations. So most communication satellites are in geostationary orbit 22,236 miles above the equator, so that the satellite appears stationary at the same point in the sky. Therefore, the satellite dish antenna of ground stations can be aimed permanently at that spot and don't have to move to track the satellite. The high frequency radio waves used for telecommunications link travel by line of sight and so are obstructed by the curve of the Earth. The purpose of communication satellite is to relay the signal around the curve of the Earth, allowing communication between widely separated geographical points. Communication satellites use a wide range of radio and microwave frequencies. To avoid signal interference, international organizations have regulations for which frequency ranges or bands certain organizations are allowed to use. These allocations of bands minimizes the risk of signal interference. So there are different types of satellites. Research satellite, which measures fundamental properties of outer space. Then weather satellites help scientists study weather patterns and forecast the weather report, and also they help to show that the ozone layer was being depleted. The news that we get through radio, television, newspaper are obtained by the use of weather satellites, and it is due to weather satellites the weather forecast is possible about rainfall, wind, cyclone is possible quite in advance. And these weather satellites can help by informing whether a forest is on fire or there lies an iceberg in the course of a ship. And weather satellites also can be used to identify the pollution of soil, air, and water. And these navigation satellites, mainly we travel by car, trains, ships, and planes. Navigation satellites are used to locate the exact position of the vehicles, marine vessel, and aeroplane, especially when they are lost or accident happens. Navigation satellites mainly intended to help determine the position of aircraft, ships, and submarines with great accuracy. Earth observation satellite used to map and monitor our planet's resources and ever-changing chemical life changes. Overall, these satellites can give us the clean pictures of Earth's surface because it can take photographs from high altitude or high height and can observe the position of the ships in the sea and possible leakage of oil from ships causing pollution. They can observe the fields of crops over vast areas and find out where crops are growing well and where there is invasion of insects. And Earth observation satellites are also used for discovering minerals and locate mountains and forests with great accuracy. And astronomical objects also used to observe the planets, stars, galaxies, and all objects in the sky by carrying telescopes much above the atmosphere. So this gives better visibility because light rays are not scattered by the air molecules of the atmosphere. So dear learners, today up to this, and by this content the chapter outer space and satellites has been completed. So thank you all. Stay safe and stay blessed at your home.